Hello, my name is Xander. Welcome to the Python Beginners Plus course. In this tutorial, we're going to explore the concepts of asynchronous programming to give us a high-level view of this programming paradigm in Python. Let's just start with an example to give us some context here and just to build up a picture. Right, so if I was to ask you to send two emails to two separate people, probably what you wouldn't do is compose an email, send it to user A, and then wait for a reply. That could take however long that might take, an hour, a day, or a week, and then you would respond. So once that's completed, you would then start the second task, which is composing the second email to send to user B, and then the same process again, wait for a reply and respond. So you can see straight away that's a complete waste of your time waiting for a reply before you even do anything else. Although you might be making lots of money waiting and doing absolutely nothing, ultimately you're not going to get much done. So you're probably going to tackle the task like this. You're going to compose an email, you're going to send it to user A, and then you're just going to wait for a reply. And then in the meantime, you're going to compose the second email and then send that to user B and then wait and reply whenever you get the reply and then start another task and so on. So that seems like a much more efficient way of managing your time. So let's put this in a context of a program. So let's put this idea in the context of a program. So far in the Python Beginners course, we've been developing small applications. We could say that we've been utilizing a synchronous method in that, for example, we create a task to be completed, maybe an if statement, that completes, and then maybe another if statement starts, or maybe we call a function, that function completes, and then another task takes over. So let's take a look at this example here, where we're just simulating the idea of sending and returning email. You might be able to see what's going to happen. We're going to start this program, run the first function. We're going to send our first email, we'll just print out send first email, and then we're going to get a reply. But it's not until we get the reply that we can then perform another action, in this case this new function, and perform some more code here, and then send the second email and then get a reply and then so on. So here we're working synchronous, in a synchronous manner. So we're waiting for this function to complete before we can then start this next function. So asynchronous, or working in an asynchronous way, is going to allow us to send the first email and then wait for a reply, send the second one while we're waiting, and then send the third email while we're waiting. And then as and when, in whatever order we get a reply from any of these email requests, we can then deal with them inside the program. So now I've transformed that example into asynchronous code. Now, I'm not going to explain this just yet. We're just going to run this, and then we're going to work through this step by step, working up to this point. But you can see here what's happening is that we are printing out, or we are sending our first email. But now what I'm doing, utilizing asynchronous tools, I'm now telling Python that, okay, I've sent my email and now you can go and do something else. So we start another task concurrently. In this case, we fire off this next task, which will then also send an email. And then we can do the same thing again. Okay, now we can send off this email, for example. Now what we're doing here is we're just simulating, like it says here, that the email takes, for example, 2 seconds before we get a reply. So we can turn that into any seconds. So let's do this. Let's put this as 5 seconds. This is 2 seconds. And this is going to take 1 second. Okay, so that's how long it's going to be until we get the email back. Now, as soon as we get the email back, or the timer goes down to 0, it means that we've received an email. So we're just simulating this. And then the next task is going to happen. So we're going to print out first email reply. So let me just show this in action. So we see here that first of all, synchronous, using synchronous code, we sent and received. So here using asynchronous code, let's go ahead and run this. You can see straight away that we've sent our first, second, and third email. And notice there you saw that the third email, that only took, because that took less time, that happened first. So we received that, and then we received the second email, and then we received the first email. So we can change these numbers around. We're just simulating the idea that this is taking a number of seconds in order for the action to take place. So here, for example, Task 1 is going to complete first, and then let's do task 3 is going to happen at the same time, and then task 2 is then going to finish. So let's do that again. So we're sending off all our emails, and now the first and the third are completed, and then we wait a couple more seconds, and then the third email is completed. So you might be asking yourself, well, when would I actually use this in a real application? Well, your application needs data. That data is going to come from a database, for example. Now that database might be on a network somewhere. It might be that there's some processing that needs to take place. So you're going to send some data to a server, a database server, a file server. There may be some sort of calculations that need to take place. Maybe you're doing some machine learning. So you'll send some data off, and then you'll expect there to be maybe a little delay. So while there is a delay in you sending data to the server for some sort of processing, you can then perform some other actions while you wait for that data to return. So this isn't the only type of action where potentially you're just waiting for data to return or waiting for some sort of processing. We can also use asynchronous programming for a slightly different context, which we'll move through as we look at some more examples. So just before we move on to some examples, building up some examples, let's just take a look here and notice some differences between an asynchronous function, which is commonly called a coroutine, and a normal function, which we're used to. And you can see the differences here is that we have this async word, and something different here, we have this await keyword. So these are two kind of key aspects of asynchronous programming in Python that we're going to learn a little bit more about. Let's start by understanding that typically this function here, what we might describe as a function normally, we now describe this as a coroutine. So sometimes asynchronous programming in Python is called Python coroutines. So this slide pretty much outlines what I've already said. Asynchronous function in Python is typically called a coroutine. Coroutines declared with the async await syntax, we've seen that, and coroutines are special functions that return coroutine objects when called. So we'll explore that in a short while. So first of all, let's just introduce Async IO. Right, so the Async IO package, this is the package that we're going to utilize, or inside of this package are all the tools that we're going to need to program asynchronously with Python. So we're going to bring in different tools, and I will introduce some of the functionality that it provides as we move through the examples. So we've already seen a number of times now utilizing the async here before defining our function. And as we previously learnt, now what we've created is generally called a coroutine. So what we have here now is our asynchronous coroutine. Now this wasn't always the case. You may see, for example, this presented in a slightly different manner with older versions of Python. So for example, from Python 3.3, this was generally the way of creating your coroutine, bringing in async.coroutine here, and then creating your function as per normal. So typically that isn't utilized anymore, and it's not considered the best approach. And I believe it's going to be phased out in Python 3.10. So currently, as of recording this tutorial, this is the preferred way of creating your coroutines. So let's go ahead and call this. So send email. So let's see if we can run this here. So I've just changed the code here slightly. Now this is a function. Apologies. Okay, so this is our coroutine here. It's called send email. So we're going to try and load that up. So I'm going to start this and see what happens. So notice here that unlike when we create a function, for example, and run that, we print out hello. This time, that's not the case. What we created here, like I mentioned before, was the coroutines are special functions that return a coroutine object when called. So let's just say that when we put the async in front of our function here, we've created a coroutine object. Now this object needs to be run. We need to tell Python to run this object. So what we need to do is bring in some tools from Async IO. Right, and then we're going to need to utilize run. And we just need to then define what we want to run. So that's going to be the send email coroutine. Okay, so now we're actually going to run this coroutine. So it should now print out hello, and there we go. So like checking for data types, we can also check to see if our function is a coroutine by utilizing print and then bringing some more tools in from our Async IO. And then here we're going to utilize is coroutine function, and then we can just name our function send email. So that's going to tell us whether it is a coroutine or not. Sorry, yep, a coroutine or not. So true, so it is. So if I were to change this, for example, to just a normal function, give that a go, we now have false. So far we haven't really run any asynchronous code at all. We've just really printed out hello. So the second tool that we need to become familiar with, probably the most important, is await. So this word here, it kind of describes what we're doing. We're now going to say, well, wait for this task to complete, await, and then perform an action. So the await command here precedes or starts a task that potentially may take a couple of seconds to complete or may take time to complete. And then once it does complete, the result of that task can then be returned, and then we can perform some sort of action. Now, typically what you'll find in examples is to simulate that, we use async sleep, for example. So sleep is basically going to provide us a way of simulating some sort of delay so we can then perform some actions and then just showcase some of the features and how to work with this asynchronous code. So here we're just going to put it to sleep for 2 seconds. So let's just put something underneath here, awake now, for example. So what we're going to do is print out hello. We're then going to simulate the idea that we performed some sort of task that took 2 seconds. And then after we get a return, or once that task is completed, we're then going to perform some other action. In this case, we're just going to print out awake now. So give that a go, hello, okay, a couple of seconds passes, and now you can see it returns, and it says awake now. So just moving away from this idea of getting data from a database or another resource on a network and waiting a little bit of time because that may take a bit of time to process, etc. How else we might want to utilize synchronous code is to make our program flow in a certain way. Maybe we want to utilize this to perform certain actions in a certain order, for example. So let's just take this example here. Imagine we had a number of different tasks. So let's just say T1. So we'll just start off here. I'll just make a few tasks. T1, T2 for task 2, and then task 3, for example. So we've broken down our application into smaller components, and we know that potentially we want to perform an action in some of these tasks and then hand over to another action. So we can control the flow of our application. Right, so let's go ahead now and run await. Okay, so we're going to wait, for example, in this case, T2. All right, so what's going to happen here is that we're going to start off by running T1, task 1, and then once task 1 fires off, we'll then start task 2. And then what we can do is we can then, in task 2, say, well, actually, you can now run task 3, for example. Right, so let's go ahead and just print out task 1 there. Let's print out task 2 here, and let's print out task 3. So let's just give this a go and see what happens here. So you can see that we return task 3 first, then task 2, then task 1. So you can clearly see this idea of using await to hand off to different tasks. And this task here will then hand off to this one. We then print out this. Now this is completed. So the await here now responds because this task has now been completed. So we awaited for this task to complete. It's completed. So therefore we run the print. Now we know that this task is now completed. So we were waiting for it here, remember, waiting for that to finish. So now we print off T1. So you can see that is the case by the order in which we printed out T3, T2, and T1. So you might be wondering, well, how the hell would I actually put this into my application? When would I actually still use it? So it can be a little bit abstract at the beginning, utilizing asynchronous code. And there is obviously a lot to this. This is a very difficult topic as you move further into this topic. But these are the basic principles, and hopefully that we've established that. Hopefully I haven't over-embellished. Let's try and establish a more concrete example here. Let's go ahead and create an async function here called email reply again. Right, so this could be an email reply. Let's call this a data reply. Okay, so let's await. So we're going to use, for example, the sleep again. Okay, so we're going to sleep for 4 seconds, and then we're going to return something. So we're going to return, how are you doing? Let's return some data in actual fact, shall we? Let's go ahead and return a dictionary. Okay, so data 100. There we go. So this here, let's just pretend this is somewhere on the net, on the web, and we're now going to send a request to it so that we can perform some sort of action. Right, so that's our server somewhere. We're going to send a request to that server. It's then going to process. Now we're just simulating it's going to take 4 seconds to process, and then it's going to return our data that we requested, although we're not really requesting anything here, of course. Right, so now let's build our task. Right, so let's call this task 2, and let's go ahead and run a request. Apologies. So we're just going to print, first of all, let's print waiting for data. Okay, so we're going to wait for data. Cool. And now what we're going to do is we're going to await. So we're going to send our task off to the server, which is going to process our data. So that's our data reply. Right, so we send our request off. Now, when the request is finished, we're going to find out, and then we're going to return this data here into our X variable, and then we can print it out, right? So let's print it out. There we go. So you can probably already see what's happening here. Let's just run our task. It's then going to print out waiting for data. We're then going to send a request for our data, make some sort of data request. We're pretending this is somewhere maybe online, so it's a server that processes our data. It's going to take 4 seconds. Let's just make it 2 seconds so we don't have to wait so long. And then it's going to return our data. So let's give that a go, waiting for data. And there we go. So now we've got our data, we can perform some sort of action. Okay, so in the meantime, although this setup here hasn't provided that, in the meantime, what we could do is we could tell, while we're waiting, we could tell another task, or we could have another task running. So let's give that a go. Let's create another resource. Let's call this a file reply. Well, so we're going to get a file from a server. That's going to say 4 seconds. So we're going to return. Let's just return, for example, file returned. There we go. Right, so we've got some sort of service here that we're going to request. So let's now go ahead and let's just make task 1. Let's make this into task 1. And then let's create another task 2. So task 2 is going to be waiting for file. And then we're going to request our file. It's the file reply. bring this down. Okay, so we're going to fire off that. It's going to take 4 seconds to respond, and then we're going to print that out potentially. Right, so those are 2 main functions. Again, we're just pretending that's maybe somewhere on a server somewhere else, and we're just pretending this is a function that's actually going to fire off a request for a file or some data. So let's now build a controlling function, a function that's going to set up everything and fire off all of our other coroutines. So we're going to call this main. So let's go ahead now and create this. So an async function, we're going to call this main. Okay, so now what we're going to do here is use some other tools. Right, so we've got 2 tools that we could utilize here. So we can start both tasks potentially at the same time. So we could try and run these tasks concurrently. So let's have a look at this. So let's go for x equals, and then we're going to run from Async IO. Let's bring in the create underscore task. Right, so that's going to allow us to run this task. We're going to call this task to run. That's task 1. And what we can now do, for example, is if we remember to say, okay, so now what we can now do is, well, we can do the same thing for task 2. So let's start task 2 and let's get everything that's returned back in Y. So that's now all set up nicely. Okay, so that's going to essentially call these tasks and get them running. Now, what we need to do here is await them, because what we want to do is we want to potentially return something from them. So let's await them, see what they return. So sorry, it's X, and then also we can await Y. Okay, so let's give this a go and see what happens. So we're waiting for the file data, waiting for the file. You can see that we've returned the data, and then we've gone ahead and returned the file. Okay, so you can see how potentially that is working. We've fired off, or we've started our 2 tasks utilizing create task, and we've awaited them. And then what's happened is our tasks have started. They've obviously fired off our other functions here, which have a sleep timer, just simulating the idea that they take a few seconds to be processed. And then when they're ready, we then return some information. So the await here is expecting a return, and it's then saved into X and then printed out in the terminal. So you may be wondering, well, how does this actually work? What's going on behind the scenes when we await? So what's actually controlling, what's actually managing the wait and actually then responding when there is a response, for example, from the servers? So to kind of move into that area, there's a concept or the idea of an event loop. So as soon as we have a wait, what we're doing is we are managing and controlling that task in the event loop. So I like to think about the event loop as a very efficient task manager. So we know that we create a coroutine that creates an object, and then we use a wait to initiate that object. So the event loop we can say is managing that await, is managing for example, the request, and when there's a response, it can then deal with that response and then return it back to our program, say, in order to perform other actions. So it runs asynchronous tasks and callbacks and coordinates the tasks. So put it into a picture, our application, it sends a request, or it starts a coroutine. The event loop is going to manage that coroutine, send a request to the server, and then we get the reply, and then the event loop will deal with that reply, and that would go, for example, back into our application so we can perform some actions. So just exploring this code here, you may be wondering, why do I need to await? Because, for example, I briefly mentioned Async IO create task. That's going to initiate a coroutine here. So if I remove this code here, let's just explore what happens. So for example, here I'm running, and you can see what all it's returning is a waiting for data and waiting for file. So you can clearly see that the create task is firing off our coroutine in print, but because we're not waiting, because we've taken the await out here, we're not waiting for a reply at all. So moving that back in and using await, that ensures that we're waiting for a reply and we get the reply, in this case, the data. Obviously, we're just printing it out here, but it does mean that it then deals with that response, how we set it out here in this program. So let's put our new knowledge into action by completing some code challenges. So the first code challenge here, we're going to create 3 coroutines named T1, T2, and T3. So each coroutine should print out the name of the coroutine. So we're going to call or run the first coroutine, and using await, have T2 print out first, T1 print out second, and then T3 print out last. So by all means, go ahead and have a go, and then we'll have a look at the solution. So here we have our 3 coroutines. We're going to start off by calling T3. That's going to await T1, and then that's going to await T2. And then it just runs back in order, T2, T1, T3 in terms of the printout. Here we go. Okay, so this is a little bit long-winded. Let's build a coroutine called fetch data, which simulates the collection of data from a network database. So similar to our last example that we completed. Let's assume that it takes a few seconds. It should return a dictionary, data 100, and then next build a new coroutine which counts down from 10 to 1 using range. So we're going to use await, have each number printed to the screen every 2 seconds. Okay, then finally build a coroutine called main and run fetch data and the countdown coroutine concurrently. So we're going to print the data that is returned from fetch data while also counting down from 10. So we're going to have 2 coroutines. One's going to just count down from 10 every 2 seconds, and then that's going to appear in the terminal, obviously 10, 9, 8, 7, 6, so on. And then in the meantime, we're also collecting data from a data source, in this case, a network database, for example. So this is just going to give you and establish that idea that we're kind of performing activities whilst also performing another activity in the background. Right then, so let's go ahead. Apologies if that wasn't very understandable, if you didn't understand that, that text. So we're going to create a new coroutine here called fetch data. We're going to print fetch data or fetching data, and then we're going to wait. So we're just going to simulate the fact it's taken 2 seconds to process the data, and then the data is going to return data returned, and then we return some data. So we print data returned and then actually send back some data, and then that's our fetch data coroutine. Right, so now we're going to create a new coroutine, call it task 2, and then we're going to create our range here. So we're going to have it count down, and then utilizing a for loop here, we're just going to print and down. We're going to use a for loop, to count down from 10, and we're going to use a wait here, right? So we're going to put it inside of our for loop. So what's happening here is that we're going to print, and then we're going to use a wait, and of course we can use sleep here, which is going to kind of pause that for 2 seconds, isn't it? So in this case, so then we're going to then run through the for loop again, 10, 2 seconds, 9, 2 seconds, and so on. So that's going to give us that type of action. So let's build our main, and let's utilize create task to fire off our 2 tasks. And then we're going to await X. That's going to return some data, remember? So we're returning from the server some data. So this time we're going to create a variable and await, move the data into a new variable and print it out. And then we're going to await Y as well, and that's going to count down. Right, so once we've done that, let's fire this all off utilizing Async IO run. So fire off our main. That's going to then start our tasks via the await here. So we're going to wait for them to finish and then deal with anything that is returned. So there we go. So with that in mind, let's have a look to see what this looks like. So we're counting down. Now you imagine after 2 seconds, you can see that we've finished this set of tasks here. We've returned data, and you can see that is being returned after a different amount of time. And if we were, for example, to move that to 6, obviously it would come deeper inside of this list here. So 0. So once we get to, I think, the third number, it's going to return some information. That would be 6 seconds. And there we go. So that was just really trying to simulate and just to establish even further the idea of running 2 tasks concurrently and producing data from tasks or fetching data from external sources, etc. So there we have an overview, if you like, a high-level view of asynchronous programming with Python. If you are still a little bit confused, don't worry. Maybe have another go. The general idea here was for you to understand the basic concepts of, or the fact that we can run multiple tasks at the same time. And I think I probably established that too much in this tutorial, so I will apologize if I've over-embellished that. As per normal, I hope this tutorial was useful, and hopefully I'll see you in the next tutorial. If you do have any suggestions or any comments on how I can improve things, or any topics that you would like me to cover, please let me know and I'll try and get back to you and fulfill those requests. Thank you very much, and I hope to see you in the next tutorial.